Hello, this video is meant to help you understand how to access, explore, navigate, and interpret solar dashboard information, whether this is from a local system or a global one. So we'll be using Sunny Portal as our example of solar dashboard software and layout. But if you have a different one and would like us to make you a personalized video, we are happy to do so. So when you open the link, the homepage you see may be different than what's currently displayed here. There are many different styles of information shown on the homepage. So we'll go over to the Energy and Power tab, and this is where we'll be spending most of our time. You'll notice that there's a day, month, year, and total tab, and we'll talk briefly about each one. Up at the top of each graph, it will display the solar array's name. In this case, we're looking at a landfill in Madison, Wisconsin, as well as the current date, which the graph will pop up on. Because it's still the morning, this graph isn't complete. And if you came back and looked at it throughout the day, it would draw the story of solar production. To navigate different days, you can click the arrows to compare the most recent days, or click on the date itself and a calendar view will pop up to allow you to go further back in time more quickly. We encourage explorations in time, such as comparing January and June, to note the differences. The idealized shape for a day's production is a bell curve in which, as you get closer to the noon hours, sunlight is more direct and more electricity can be produced. And then as the sun sets, this kind of tapers off. I'm looking for an example, but realizing that we're in December, so it's probably going to be pretty minimal. Let's jump to, oops, that's 2021. So it just takes a little bit of time to learn to navigate, but not too difficult. There we go. There's kind of your bell curve. So reading the graph, over on the y-axis, you'll have the power in kilowatts of electricity generation. And along the bottom, you'll have the time of day. And so you can kind of estimate as you look at the graph, or you can hover over the graph and see a more accurate depiction for each time frame. Notice that it's sending in data every 15 minutes. Then we'll go over to the month tab. And this is similar, even though it's bar graph. On the y-axis, we've got the electricity generation again. Note that it's in kilowatt hours because we're displaying higher amounts of numerical data. And along the bottom are the days of the month. So you can see that there are differences between each day. It's not consistent in its production, especially as you get into the fall and winter. And if you click on these graphs, you can see the exact production of the day. So that's useful for talking about comparing days. So if you find a day you like in the day tab, come over to the month tab and it will give you a quick overview of how much it produced. Similar with the year. So we can see kind of that same bell curve as we get into the summer months, more production on average, and then tapering off. Because we're in the northern hemisphere, as we get to summer, the days get longer and the angle is more conducive with producing higher amounts of electricity. And finally, in the total tab, we can see the amount per year, and that these fluctuations don't quite average out. You have fluctuations in yearly production as well. And as 2021 continues, this bar will continue to grow. Other pieces of information that can be useful for your exploration. Some dashboards will display the current production that you can view easily and talk about what are the weather conditions outside right now. You can see the display for the current up to day. So watch this number. If you showed it in the morning versus the afternoon, watch it grow. And the total. This is in megawatt hours, all those kilowatt hours added together. Another informative piece is the carbon calculator. So this will tell you that by creating solar electricity, we avoided the CO2 from other sources of electricity, such as coal. And if your dashboard does not have a built-in carbon calculator, simply take the kilowatt hours from a particular day, week, month, etc., and plug it into the EPA greenhouse gas equivalency calculator, and it will tell you the CO2 as well as some other metrics for your students. Finally, we want to talk about the KWP, which is essentially how large your system is. What is its maximum potential of solar production? And so again, not every dashboard has this listed. This one, it says, is approximately 6.3 kWp. And for our sake, we simply need to know that a larger number means on average it will produce more electricity. So Sunny Portal has a system, and you can find this by simply searching public Sunny Portal solar dashboards. And you can look throughout multiple countries or cities throughout the US. There's lots of different ways you can engage this information. But when making those comparisons, it's important to look at the KWP, because it's not fair to compare a larger KWP to a smaller one and assume the differences are due to location only. To do these kind of explorations, HEAP has also created a map of global solar dashboards with a lesson for inquiry about differences in production between sites, within the same site, and allowing students to uncover kind of where is the best location or locations for solar, what other locations can do to kind of bolster their production, and make recommendations for where they would put solar panels. So if you're interested in that lesson, we will have that linked in our solar hub, as well as additional resources and background on ways to make these connections. If you'd like more information on how to connect, we also have a solar dashboard online Canvas course that you can take at will and study this topic and the background of electricity usage data and the state of renewables in Wisconsin and across the country and why it matters, to kind of put this information in a larger context, such as for teaching a unit on renewables. And as always, if you have any additional questions, feel free to reach out to HEAP